of course, I'm in the corners.
Okay, thank you. The next speaker is Marina Lipizer. Broad ranges for quality control of coastal data related to marine eutrophication, the Mediterranean Sea case study.
Thank you. Is it the presentation already open? No, I have to close it. Okay, this one? Yeah.
Double click, yeah, comes.
Presentation mode.
Slideshow.
Yes.
Yeah.
And it's there? Yes.
So,
Okay, good morning, everyone. My name is Marina Lipizer. I am from the Italian National Institute of Oceanography and Applied Geophysics. And this work results from the collaboration with the colleagues from the Hellenic National Oceanographic Center in Greece. And it's about improving system to quality control data related to marine eutrophication using the Mediterranean Sea as a case study. So in order to start with a common understanding, what is marine eutrophication? It is a process driven by the enrichment of water by nutrients, leading to water quality degradation. And it is one of the 11 descriptors of the environmental status, according to one of the main European legislations, which is the Marine Strategy Framework Directive. And it's also an ecological indicator assessment by regional sea conventions. So it's quite an important indicator of the sea state. The Mediterranean Sea is usually regarded as an oligotrophic basin, so low nutrients and chlorophyll. However, it is characterized by several well-documented eutrophic areas, such as in the northern parts, and which are especially related to coastal areas, close to continental inputs, land-sea interactions and human activities, and so on. And in eutrophic areas, nutrient concentrations can reach very high levels in comparison with open waters. So, needed to assess eutrophication at a basin scale, there is of course a need to use multiple data sets from heterogeneous sources and also collected over years. So data quality control, it's of course a fundamental steps in data management. And what is traditionally done is to do control on metadata and on data, which consists on, well, null missing values, range check in global, using global checks, but also regional. This is to verify if data lie within expected extremes encountered in the oceans in a particular region or period. But these ranges are now available for the open waters. So these regional ranges may not be suitable for coastal waters due to their high natural variability. I show here as an example some plots using all data, so data without any quality control being done. The map on the left, is just a surface distribution of nitrate, one of the nutrients in the North Adriatic. And the red line on the plot represents the regional range, which is currently used to validate data. So if we use this range, we will remove all the signal of eutrophication. So coastal eutrophication will be no longer visible. And this is not really what we want. So the purpose of this work was to evaluate ranges of biogeochemical parameters in coastal waters to help this evaluation of data quality in immunet chemistry. The approach was, first of all, what we need, what we defined as coastal waters. And we know that, according to our oceanographic knowledge, we know that river inputs extend far into the sea. So first we were thinking how to define the coastal waters. And in order to have a standard method for the whole basin, we decided to use official layers. So we based on the EA coastal waters, which are, however, available only for the EU states. This is why we have to do the analysis only for the EU states. And in order to support the MSFD, we did this analysis for each sub-basins. So we used the AAA files, the AAA shape files. We used EMODNet chemistry aggregated data sets, and we selected only coastal waters and also transitional and territorial waters, and we split this also in different depth layers in order to do the analysis, the statistical analysis of several subsets of data. So for each subbasins, for different water types, different depth ranges, selected parameters, selected statistics, and then we compare this with the existing upper ranges. So what we ended up with, this is, for example, just the nitrate, one of the nutrient concentration in the different subbasins, the 4 subbasins, in the coastal waters, the green on the top, in the 0.75 range and the 75 to 100, and in the open waters. We also calculated the 99th percentile of all data and also the maxima. And we compare this using all data and quality flagged. So we see that validated data and all data do not show remarkable differences except for the maxima, and maxima are visible only in 2 subbasins, in the Adriatic and the Western Med. And the highest concentrations are usually observed in this top layer, 0.75. So we did this because now we do the validation in a broader depth range, which is from 0 to 200. So now we do not take into consideration that the variability is mainly related to the top layer. So we compared the ranges with the concentrations in the open waters. So the red area, the pink area, is the range of concentration now used, and the blue and green are the concentration in all using the 99 percentiles of data. So we can say that the current ranges can be useful, are suitable for the validation of open waters. But what happens if we look at the coastal waters? The situation is quite different. So the pink area is the maximum range of concentrations now used, and you see that most of the data are quite above. So even the highest upper range will not fit a large part of the data in the upper layers, and ranges are too low even for the bottom layers in the Ionian, in the Aegean Sea. So you see, this is why we lost all the eutrophication signal. We looked in the literature, and we used the MSFD reports provided by the member states to compare, to see if the data we find are really bad, they are really out of range, or they are really environmental signals. And the MSFD reports confirm that these high concentrations are typical of really coastal waters. So then we did this analysis also for other nutrients, and the results are similar. So there is really a clear need of revised regional ranges for coastal waters. And we did this for the Mediterranean now as an example. Taking into account that the data distribution is not normal, we propose to use non-parametric statistics. So we used the 99th percentile of data as a limit for the quality flag 1, and the maximum of all data encountered in these data sets as the quality flag 2, which is according to the CDataNet standards, is the limit between probably good and probably good data. And data above the maximum are considered as probably bad. We are still working on this. On this process, on these limits, but we think that these statistics are more representative than the standard deviation which has been used so far. So, considering the statistics of the major nutrients, we can say that the existing concentration ranges are adequate for the open waters, but for the coastal waters, higher upper ranges should be adopted. And this work also indicates the importance of introducing an additional upper layer, because the concentrations in the upper 0.75 are much larger and the variability is much larger than the underlying layers. And the comparison with published data supports the correctness of the ranges. And we also have to point out that in coastal waters close to human impact, even the maxima need to be carefully inspected to evaluate if they are realistic. So literature comparison and expert knowledge are really important. And we think that this methodology can be used also for other sea basins. However, we faced a set of shortcomings. For example, there is a need of shapefiles of official waters. So I really enjoyed the presentation given yesterday by our colleague from Blitz on marine regions. So we really need coastal waters for all countries. And we also need to easily filter coastal data to support data validation. And again, I also recapped what was shortly said before by Antonio, that anyway, these coastal layers, these official layers are artificial because we know there is a continuum between inland, transitional, and coastal and open water. So even the continental inputs may extend far, far beyond the so-called coastal waters. So in the next step, we will do this analysis also on other water types and implement this into the standard validation process, which is carried out within IMONET chemistry. But again, I would like to point out that expert knowledge is always required for coastal and transitional areas, and not only automatic QC is needed. However, with the new improvement in artificial intelligence, maybe this can help to further set rules to improve our quality control. So I thank you for your attention.
Maybe time for one question.
Hi Marina, thanks for your nice presentation. Do I understand it correctly that finally you apply the automatic quality control checks and then you do a visual check again, and in the final product we have a mixture of automatic checks and manual human checks. Is that true?
Okay, so there is an automatic check at the beginning, yes, on all the data sets which come to IMONET chemistry. Then there is a large harvesting, and all data are aggregated into a single aggregations. And then there is visualization. No, there's an application of rain check also at regional scale. And this visualization was done later on, but it's not it's not the basis of the validation. I mean, it's only the automatic check.
Also to complement that, okay, there is the automatic control, but of course always, as you know, a manual, visual, human validation is needed in order to give the final green light for the data to go to the next step, which is products preparation. Because automatic control is not sometimes, especially in coastal areas, sufficient to give you the correct results.
And also, I know there is a contact with the data originator, so before...
Yeah, always a contact with the originators in case of change in the flags that we are provided by the originator. So there is a complete feedback quality loop to ensure that we do our best, in any case, to ensure that the highest quality of data is served to the users. So thank you, Marina. We can go now to the next presentation.